Today, we're going to dive into a pretty radical thought experiment. Forget distant exoplanets for a minute. What if we reimagine life right here on Earth? We're exploring the world of the sulfur pulse, a speculative concept where the very rulebook for biology gets tossed out the window. So get ready for an Earth that's both alien and just a little too familiar. Just listen to that line: bruised orange sun, great acidic sea. Right away, you know this isn't just about a different climate or a weird weather pattern. Something is fundamentally chemically wrong with this place.
And that's the kicker, right? This is our home. But it's like an alternate reality, an Earth that took a hard left turn at the dawn of life. It's a world where the chemistry itself forked, creating a planet that we could recognize on a map, but one that would be utterly hostile to our very existence.
Okay, so to really get what's going on in this story, we gotta get the ground rules straight. We need to understand what's normal in this, well, perfectly toxic paradise. First thing you need to do, forget about water. Just erase it from your mind. Here, the oceans, the rivers, the very blood in the veins of its creatures, it's all concentrated sulfuric acid. And it's totally stable at the average surface temperature, which is a blistering 160 degrees Celsius. For them, this stuff we consider a terrifying corrosive is the cradle of all life. And the air? Just as friendly. It's this thick, heavy, crushing blanket of sulfur dioxide. It's so dense it filters the sun into a dim, yellowish green glow, and the atmospheric pressure would just, well, it would flatten you like a pancake.
So how does anything even get energy in a place like this? Well, you don't breathe oxygen, that's for sure. Life here inhales a cocktail of hydrogen sulfide and sulfur dioxide. Their bodies have created a natural version of an industrial process we call the Claus process. It's basically a biological furnace that creates pure sulfur, steam, and all the energy they need to survive. Wild, right?
All right, so now that we have a feel for this beautifully harsh reality, we can get to this central mystery. Because scientists there just found something that, according to all their laws of biology, simply should not be possible.
This is where we meet our main character, a scientist named Kaelen. For him, everything he thought he knew is about to get turned upside down. Deep-sea sensors have picked up something in the Marianas Trench. They're calling it the Deep Anomaly. It's a huge structure that looks artificial, and their science says it absolutely cannot exist.
So they hit it with every sensor they have, and the data that comes back is just baffling. Look at these properties. It's made of something they call carbon hydrate polymers. Now, to a life form based on sulfur, carbon is, well, it's basically a rock. It's like a microscopic fortress. It's rigid, it's inert, and it's completely useless for the fluid, flexible chemistry that they consider life. It's just a dead mineral.
So what do when you find the impossible? You go look at it, of course. Kaelen and his colleague Vern get into a submersible and start the long, dangerous descent into the acid ocean. They're basically hunting for a ghost from an entirely different reality. As they get closer, they get a temperature reading from inside this thing, and it is absolutely terrifying to them. It's 20 degrees Celsius. Now, for you and me, that's a pleasant room temperature. For them, it's a deadly, unsurvivable freeze. A cold so intense it would crystallize the sulfuric acid in their veins, killing them instantly. They're not going in there, obviously, so they send in some micro-drones. And what the drones find is just one bizarre discovery after another. The inside isn't full of acid. It's full of liquid H2O, water, a substance they only know as a super hot gas. And scattered around are skeletons of two-legged creatures made of this fragile, weird material called calcium phosphate.
But the absolute biggest shock, the most horrifying discovery of all, is the air. The drones are reading an atmosphere with 21% free oxygen. To their biology, which is built on these delicate, easily broken sulfur bonds, oxygen is a nightmare. It's a violent, destructive element that would literally rip their molecules apart. To them, oxygen is the definition of poison.
And this is the moment it all clicks. This slide just lays it all out. Kaelen is staring at the complete chemical inverse of his own existence. On the left, you've got them, fragile, fluid sulfur chemistry that works in extreme heat. On the right, you have us, rigid, strong carbon chemistry that needs a violent element like oxygen just to get energy. It's a total flip of what the word life can even mean. So that raises the biggest question of all, right? How could two completely opposite types of life exist on the same planet?
Well, the answer isn't in space, it's in time. It's buried in the planet's own violent past. This is what Kaelen figures out. Earth wasn't always a sulfur world. Once upon a time, it was our world, cool, wet, and full of oxygen. But then came the cataclysm, a period of insane volcanic activity that pumped billions of tons of sulfur into the air, creating a runaway greenhouse effect. The watery oceans boiled away and became acid seas. The cold world of carbon died, and the hot world of sulfur, which had been hiding out near geothermal vents, finally came out and inherited the Earth.
And in a moment of perfect, tragic irony, just as Kaelen solves this incredible puzzle, his investigation triggers the end of it all. The very act of observing this ancient place destroys it. The fragile balance that protected this tomb for millions of years is about to be broken.
The dome fractures under the immense ocean pressure, and you have superheated sulfuric acid pouring into the cold, liquid water environment. It's a chemical reaction of unimaginable violence, releasing a colossal amount of heat in an instant.
The temperature inside that dome spikes to over 900 degrees Celsius. The water doesn't boil, it flashes into superheated steam, creating a massive explosion that hurls their submersible backwards. And in a blinding flash of heat and chemical fire, the two opposite biochemistries just annihilate one another. The very last trace of Earth's carbon-based past, our past, is incinerated, dissolved, and wiped from existence by the dominant chemistry of the present. The anomaly is gone. Forever.
So, wow, what do we even take away from a story like that? It's incredible, but it's also deeply tragic. But what does it really tell us about our own ideas of life and what makes a planet habitable? This quote from Kaelen just nails it. One kind of life didn't win. The planet itself just changed its mind about what kind of chemistry it preferred. And all those words we use, habitable, toxic, paradise, hellscape, they're completely relative. They only make sense from our very specific point of view. I mean, think about it. Our beautiful blue and green paradise, with its cool water and life-giving oxygen, to them, it's a toxic, corrosive hellscape. And their thriving, gorgeous world of hot acid and subtle sulfur reactions is a place we couldn't survive for a single second. It is all about perspective. And that's the final thought I want to leave you with. If a single planet, our planet Earth, could have hosted two completely opposite blueprints for life, what other kinds of biochemistries, built on rules we think are impossible, are flourishing out there in the universe, perfectly at home in their own beautiful, toxic worlds?
Please like and subscribe.